Welcome to Lesson 19, Learn C Programming on the Raspberry Pi. Well, today we're going to do a little more work with LEDs, except that we're going to try to make an LED vary its luminosity. In other words, make it go bright and make it go dim under our control. And we're going to do that using a feature on the Pi called pulse width modulation, or PWM. So let's get on with it. Let's start by going over to our Pi. And bring up our editor here. And we'll start with just a little bit of theory, I guess, and also just to go over our previous day examples. If you take a look at what we did last day, you can see we worked with the Fibonacci sequence, and we had the person enter in the first two terms and how many terms they wanted, and it would go through printing out these terms, and it would also print out what the golden ratio was. And that was in lesson 18. So let's just go there for a minute. 18, and we'll just run that. Enter the first two terms followed by the number of terms. So if the first two terms are 0 and 1 and we want 12 terms, then there's our answer. So the first two terms were here, and we have 12 terms altogether, the last term being 89, and the golden ratio is 55 divided by 89, which gives us 0.617977. Okay, so we went over that in the last lesson on lesson 18. I hope you had a chance to look up Fibonacci on the web, in Wikipedia, and other places, and discover what a great mathematician he was. Let me now say, I'll make another directory for today. Lesson 19. Okay. So we'll go to lesson 19. We have nothing in there now, but we'll start with something. So what I want to do is I have a one LED already wired up. Happens to be a green LED. And I have it wired through a 330 ohm resistor, and I have it wired up to physical pin 12, which is the GPIO pin 18. Now this is a special pin because it allows us to vary the voltage on that pin from 0 to 3.3 volts. And you might wonder how we do that. Well, that pin supplies a feature called pulse width modulation. So let me see if I can bring up a diagram. I think I made one up of pulse width modulation right here. So what we can do on this pin, and remember on the Raspberry Pi Model A, we can only use one pin to do this, what's called hardware pulse width modulation. In fact, maybe I'll bring up my notes here first. And Linux commands, C terms. I don't know if I have a topic for this. Well, I don't. Those terms. I guess I could start a new topic down here called electronics, and I'll just put in PWM, which is pulse width. So on the Raspberry Pi Model A, I'll save that. We have a feature called pulse width modulation, which allows us basically to vary the voltage. Normally the voltage as a 1 is just going to be 3.3 volts, and 0 is going to be 0 volts. So normally we just go with a function like digital write, and we can write a 1 or a 0, so we can make it 3.3 volts, or we can make it 0 volts. Straightforward. Okay, so let's take a look at this diagram I have here. Pulse width modulation means that we are sending out a bunch of pulses, like square waves, I guess you could say, or close to square waves, and we can vary the duty cycle. So if you look here, for example, 50% duty cycle means that the voltage is on for half the time, which means it's at a 1 level here, or 3.3 volts, and then it's off down here for the second half of the cycle. So if you think of 3.3 volts being on for half the time and off for half the time, then the average would be 3.3 volts divided by 2. So if I go into BC and I say 3.3 divided by 2, so with a 50% duty cycle, I would have 1.65 volts, so the LED would be lit up to half its brightness. Well, if I went to 75% duty cycle, then it's 3/4 of the time it's on and 1/4 of the time it's off. So for 3/4 of the time, it's working at 3.3 volts, and at 1/4 of the time, it's working at 0 volts. So in that case, we would have 3.3. What would it be? Times 3/4 times 3/4 would be 2.4 volts. So at 75% duty cycle, we'd have 2.4 volts. And then of course at 25% duty cycle, which means it's off, you can see mostly it's off, but it's only on for 1/4 of the time. So if you look at 3.3 volts and 1/4, then you can see it's 0.8 volts. So with 25% duty cycle, it's 0.8 volts. Well, what I suggest you do, it's probably a good idea, would be to go on the web, look up pulse width modulation, read about it, and you could also go on the Raspberry Pi documentation and see that this pin, GPIO 18, gives us or allows us to use pulse width modulation, which means we can vary the voltage on that pin. Of course, on the newer Raspberry Pis, they have 2 pins that are hardware pulse width modulation on the newer Pis. And of course, one other thing I should mention is that we can emulate this feature using software. So it's quite possible to use any pin, any GPIO pin, as pulse width modulation, but we'd have to simulate it with software and not hardware. Hardware, it's always better to do it that way. I suppose there are reasons that I'm not really familiar with it, but Anyway, we'll get into software pulse width modulation in later examples, but today I just want to work on this one pin on the Raspberry Pi A GPIO 18 that allows us to use pulse width modulation. And so we have to use a function. Let me get out of this BC here. We have to use a function called PWM right, pulse width modulation right. So let me add that in here to our wiring Pi library functions. I'll add that in as a new one down here called PWM right, and I'll show you how it works. So let's get ready and show you that. Well, I guess I should have done it in here. Where is it here? Let's see. PWM right. Okay, let me save that guy here. Okay, so let's go and see if we can do an example here. I'll do away with this Fibonacci, and I will start a brand new file here. And let's just start as we always do. Include bracket stdio.h number sign inclu include std.h and number sign include pi.h. Okay, you notice I've included something new here, this UNI std.h, and I'll explain that. The main reason is that up to now, all the Raspberry Pi examples we've been using, we were running as an unprivileged user. In other words, as a non-root user. But today, since we're going to be using the PWM feature of the Pi, we have to run our program as root, as the privileged administrator on the system, and we'll need to check that. And so we'll be using a function to check to make sure that we are root. Okay, well, we'll get to that as we go through. But I've got a green light here. So let's set that up using a define green, and it's going to be on GPIO 18. I also want to define a pause as, let's say, 10 milliseconds, because as I make the light vary in brightness, every 10, I'm going to change the voltage on it every 10 milliseconds. Okay. We'll start with main. We need a control variable for our loop. And now this is something different now. What we're going to do is we're going to check now to see if the person running this program has root permission. In other words, is the person running this code the system administrator? So get user ID. If it's not equal to 0, because the user ID for root is 0. For example, if I go on the Pi and I look up the Pi's ID, the user Pi's ID is UID is 1000. Okay, but the ID for root is 0. So we want to check here using this function, and this function is part of the standard C library, and it's defined in this header file. So we're going to check to see if it's not 0. If it's not 0, that means the person is not root. So I'm just going to put in a printf you must be root to use PWM. So I'll just do something like that. And I'll return an error code of 1, say, or an exit code of 1. And that's it. So this will ensure that the person is running this application as root. Well, now we have to go through our wiring pi setup. So I'll say pi wiring pi setup GPIO, and then I'm going to set my pin mode just like I did before. I set my green pin, which is pin 18, to output, and I'll also initialize it to 0. Oops, should be uppercase. Okay, so I've initialized my LED to 0 volts, which means it's off. And now what I'm going to do is I'm going to change the pin mode now again. PIN pin mode green. So this is going to be something new now. I'm going to set it to PWM output. And remember, I can only do this on GPIO 18 on the Raspberry Pi Model A. On the Model 3 or B pluses, you have more PWMs available. But on the Model A, you only have one pin that can do hardware PWM. Okay, so what I want to do now is I want to turn the light from darkness to full brightness. So I'm going to do a PWM write function down here that I've specified here, and then I'm going to do a for loop using this counter x. So I'll say for x equals 0, x is less than 1024, x plus plus. So I'm going to now turn the light on, PWM right, I turn the green light on X. And then I'm going to pause for a bit. Like so. So look what's happened. Well, let's save this first. Let me save this file, save as. I'll save it in 19. Where do I have 19? And I'll call this, I'll just call this pwm.c. And I'll call it pwm-led.c. Okay. So let's look at what we've done so far. I've introduced you to a new header file, UNISTD. This contains the prototype for the get UID function. So if we're not 0, if the return value of the get UID is not 0, that means we are not running as root. We are not the root person on here. We are not the administrator of the system. So we just return exit code of 1, and we're done. This could just say exit or return. We'll get into exit later. For now, I don't want to screw things up. Okay, So then if we are root, then we move on to this statement here. And we initialize the wiring pi library. We set our pin 18 to output, and we turn the light off. And then we change the mode from regular on-off mode, like up here. We change it to PWM output. And then we use this function called PWM write to vary the intensity of the LED from 0 to 1023. So let me just put that in here. 0 to 1023. So what it means is that 0, let me just put it this way, 0 to 1023, where 1023 equals 3.3 volts. Okay. So this function here, PWM write, this value x has to be from 0 to 1023. Okay, so our light here will get brighter and brighter and brighter every 10 milliseconds. We're going to switch the voltage up. So we're going to do it for 1023 or 1024, and in steps of 10 milliseconds. So that should take us 10 seconds to do that. So this whole loop here should take 10 seconds. So let's just do that. 10 second loop. Okay, so now our green light is at maximum intensity. And let's bring it down now. For x equals 1023, say x is greater than or equal to 0, and now I'll say x minus minus. So I'm just going to go backwards now. And I'm going to do the same delay. Okay, there you have it. So if we look at this, we can see now what we're trying to do here is we start off with 0 volts, and we go all the way up to 3.3 volts in 1024 steps. So very slowly, every 10 milliseconds, we keep adjusting the voltage until the light gets to its maximum intensity. And then we also have down here, we start off at maximum voltage, and we go down now, we decrement x by 1. Here we were incrementing x by 1. Now we are going to decrement it all the way down to 0. So the light should now get dimmer and dimmer and dimmer, and this is a second 10 second loop. Okay, so let's save this guy. Let's go here and let's compile it. And see if we made any mistakes. O-U-T, P-U-T. We spelled output wrong. Well, that's no good. Out instead of output. Okay, we'll fix that. Save it again. Try another compile. And this time we compiled. So now we can try running this program as non-root and see what happens. /pwm, and you see it says must be root, and returns 1. So we have an exit code here. You can say echo $? And we have a 1. So we can see where we exited our program. Okay. Now, if you don't have this test in here, and you try running this as non-root, you could end up just hanging up the program, hanging up your Pi. At least that's what happens to me. But anyway, so let's run it now as root, and we should see the green light come on and get brighter and brighter and brighter for 10 seconds. Let's have a look. So there it goes. You can see it's building up intensity. I guess you can't see it that well here, but it is getting brighter for 10 seconds, and then it's going to start getting dimmer and go down for 10 seconds. So here you can see it's starting to go down, 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 and now it's off. So it doesn't really show up that well on the monitor. Let me see if I can show it to you a little bit better. There you go. You can see it getting more intense. And then once it goes past 10 seconds, it starts to go dimmer again. And dimmer, 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 and then it goes off. Okay, so that's basically how hardware pulse width modulation works. And this is a nice feature of the Pi, because we can also control the voltage on motors. And by giving the motor more voltage, we can make the motor go faster. If we give it less voltage, we can make the motor go slower. Okay, so let's continue on now with some C knowledge, C programming. Let me go here to I want to add in this other C library function, which we used was get UID, which returns the user ID. And so today we learned that function, and we also learned the PWM write function. Okay. Oh, and the header file, we also have to add in, we learned a new one today, unistd.h for header files. And we were still using the for loop, nothing special here. And and I added in on the bottom some electronics here. And now I want to just before I leave you or leave this lesson, I want to add in another topic here in our notes called C language operators. And I have a list here. Let's I'll just cut and paste this in here, and I don't need this anymore. C language operators. We'll go over these one by one. Okay, if you look at the operators that we have in C, basically 1, 2, 3, 4, 5, 6, 7, 8 different types, but so far the operators we've been using are add, subtract, divide, multiply, where's multiply, and modulo operator. So I think by now you should understand how all these work. The only trick is when you're doing a divide of integers, you're going to get truncation. So remember, if you get say, let's say in bash, we say using bash is very similar to C. I could just say what is the value of 3 divided by 2 in bash, and I get 1. Do you see how it truncates? It truncates integers. So if I did something like, and C works exactly the same way. Let's say 10 divided by 4. 10 divided by 4 is 2.5, but it just gets truncated to, oops, I forgot to put in another brace. Let me try that again. Gets truncated to a 2. Okay, so looking at arithmetic operators, pretty straightforward: add, subtract, multiply, divide, or add, subtract, divide, multiply. And of course the order of operations follows, let's see, order follows BEDMAS. Do you remember BEDMAS from your high school days? Is brackets first, exponents second, divide, multiply, add, subtract. That's the order of evaluation. Okay. Now we learned a couple of relational operators, like, for example, say greater than or equal to, or maybe just equal to, okay, or maybe less than. So these are all kinds of relational operators. Now logical operators we haven't touched yet, but we do have some. For example, this is the AND, logical AND. This is the logical OR operator. Okay. The assignment operator is just equal sign. A equals 3. That's the assignment. Increment and decrement operators we just use, for example, plus plus and minus minus. For example, x plus plus, x minus minus. These last ones, conditional operator, we only have one of. And bitwise operators, special operators, I'll go over those as we get more into the C language. I'll save this. So I guess we're more or less done with today's lesson, or lesson 19. I just want to give you some homework. Please review all these 1, 2, 3, 4, 5 different kinds of operators that we've talked about. Review your pulse width modulation, try to understand how that works, and also some of the where do we have it here? For example, the new function we use in C, get UID, and also PWM write, part of the wiring pi library, and the new header file UNI-STD. Okay, so that's what you should be focusing on, because now we're starting to get, with lesson 20, we're starting to get more and more complicated C programs, more and more complicated work on the Pi. So it's important that you do more than just look at these lessons. It's important that as someone who's trying to learn and master C, and especially C on the Pi, it's important that you do extra work in between lessons, just to get more familiar with the terms, with the language itself, with the Pi, and things will work out. So I'm done for lesson 19. I think what we'll do now is we will stop this, and I'll see you later for lesson 20.